All right, I'm going to cover integrals that can be brought down to method of partial fractions. And in my previous video, I marked down all forms of integrals that can be brought down to partial fractions integration. So I'm going to use this form today, integral f of ax plus b to power m over n, ax plus b to power r over s, then ax plus b to power p over q, x, and dx. Okay, which means since I have here rational exponents, that means I'm going to use radicals, right? Okay, so let's start. Question number 1, we have integral dx over square root x minus 1 minus cubic radical x minus 1. Okay, so what do we have? Let me do drafting on the side. So we have x minus 1 to power 1/2, and we have x minus 1 to power 1/3. So I need to find a substitution that will cover both and 1/2 and 1/3. That's gonna be degree 6, right? For 2 and 3, it's gonna be 6. So I'm going to accept a substitution for t to power, t is equal radical of degree 6 x minus 1. Okay, now what I will need also, I will need to cover dx. So to cover dx, I'm going to go the following way. So from here I can, to get clean x from under radical of degree 6, I'm raising to power 6. T to power 6 is equal x minus 1, right? And from here, x is equal, let me move this here. From here, x is equal t to power 6 plus 1. Okay, it's getting, I think I'm going to confuse you putting these symbols here. All right. T to 6 plus 1, and accordingly dx, once I have x, I can find dx. That is going to be 6t to power 5 dt, right? Okay, now we have the dx, 6t to power 5 dt. Now let's substitute also x minus 1 to power 1/2, x minus 1 to power 1/2. It's going to be equal since x minus 1 is t to power 6, and I'm writing down t to power 6 and to power 1/2. Power to power, we multiply, right? And we get 6 times 1/2, it's going to be 3. T to power 3. And x minus 1 to power 1/3, it's going to be equal t to power 6 to power 1/3, and that is going to be t squared. Okay, we have substituted everything, all element of the integral we need. So let's write down what we are going to get from here. We are going to get, oops, we are going to get 6t to power 5 dt over t cubed minus t to power 2. All right, so, and this is going to be equal integral 6t to power 5 dt. Taking t squared out, I will have t minus 1, and accordingly t squared is gone. Here will be left only 3. 5 minus 2 is 3. Okay, and what do we have here? We are getting integral 6t cubed dt, that is over t minus 1. Yes? All right. And let me put equal sign everywhere because they all are equal to each other. Now, well, I understand that 6 will come out. That's not an issue at all. But t cubed divided by t minus 1, what can I do? At this point, for this format, for this form, there is nothing much to do. Therefore, I'm going to bring t cubed. That will be a kind of, how to say, communicate with t minus 1. What do I mean by that? What I'm going to do, at the bottom I have t minus 1, here I have t cubed. So I'm going to bring in kind of formula t cubed minus 1, where t minus 1 is going to become part of, right? Now, because I dare to disbalance the integral, so I'm going to bring back the balance, also add it 1, correct? Add 1 and put dt. So, and we are getting 6 integral t cubed minus 1 over t minus 1 dt, and plus integral 1 over t minus 1 dt. Yes? Okay. So, from here, t cubed minus 1, I'm opening formula, a cubed minus b cubed, right? Let me write down. A cubed minus b cubed, it's equal a minus b, a squared plus ab plus 1. Okay, so, and we have here what? 6 comes, stays outside. Oh. And we have integral t minus 1 times t squared plus t plus 1, right, over t minus 1, where this and this will cancel each other right away, dt. And we have here integral dt over t minus 1, right? Okay, so from here, what we get? We are going to get 6. Here we have t squared plus t and plus 1. What is going to look like? To take integral, it's going to be x cubed over 3. I mean t cubed. My God. T cubed over 3 plus t squared over 2 plus t over 1. I'm writing down on purpose over 1 so you can see. And plus, so what do we have here? dt over t minus 1. We know that integral dt over t is natural logarithm t, right? But we have t minus 1. So I can easily squeeze here minus 1 with no problem. Why? Because derivative of constant is 0. We still get a dt anyway, right? So I'm making the form for the integral. I can take out natural log t minus 1. Okay, so from here we are going to bring back our substitution. So what we did, we have our t was radical degree 6 x minus 1. Let me write down radical degree 6 x minus 1. Okay, so we are going to have 6 radical degree 6 x minus 1 cubed over 3 plus radical degree 6 x minus 1 squared over 2 plus we have radical degree 6 x minus 1 over 1 and plus logarithm radical degree 6 x minus 1 minus 1. Okay, so from here, what do we have? Excuse me. I can take this out because I don't need that drafting anymore. But here I will have x minus 1 to power 1 over 6, this very first term, power 1 over 6, and to power 3. It's going to be x minus 1, 3 divided by 6, right? It's going to be 1/2. And then same way, x minus 1 to power 1/6 squared. It's going to be x minus 1 to power 1/3, right? And there we don't have anything else to calculate. And we have it. Six x minus 1 square root, rather saying x minus 1, because x minus 1 right here, x minus 1 to power 1/2, it's square root x minus 1, right? X minus 1 over 3 plus this square, it's going to be cubic radical x minus 1 over 2 plus cubic, not cubic, radical degree 6 x minus 1 and plus natural log. Let me clean this because we don't need this drafting anymore. Natural log radical 6 x minus 1 minus 1. Okay, let's distribute this 6 also in our final answer, well, here I can put already plus c. Here also I can put plus c. So let's distribute this 6, and we will get square root x minus 1 over 2 plus cubic radical x minus 1 over 3 plus 6 cubic radical x minus 1 plus 6 natural log radical degree 6 x minus 1 minus 1 and plus 6. And we are done with this first question. So first integral. Moving to second integral. We have x over cubic radical 2x plus 1 dx. Okay. What I'm going to do, again, I'm going to here substitute, since I have cubic radical, so it's going to be, if I write here on the side, 2x plus 1 to power 1/3. There is no other radical to bring to common factor, common denominator type. Therefore, it's going to be t cubed. I'm going to take t is equal cubic radical 2x plus 1. Hence, from here, t cubed, it's going to be equal 2x plus 1. So from here, my x is going to be equal t cubed minus 1 over 2, and dx will be equal 3t squared over 2 dt. Okay. So what we are getting here, in numerator I have x. How much is my x? T cubed minus 1 over 2, right? Dividing by cubic radical 2x plus 1, it's going to be t, right? And dx is going to be 3t squared over 2 dt. All right. So from here, what we're going to do, this constant will come out 3 over 4. And what I will have here in numerator, so let me see, t squared, t cubed minus 1 dt, and divided by t. So this t is gone with this squared, right? And I'm getting 3/4 t cubed minus 1 times t. I can't here figure out any smart manipulation, so I'm going to take simply multiply by each other. It's going to be t to power 4 minus 1 dt. And from here, we are getting 3/4 t to power 5 over 5 and minus t squared. I'm doing common integral, t squared over 2. Okay, once I have that, I am distributing this 3/4 and bringing back the substitution. So this is going to be equal 3t to power 5 over 20 and minus 3t squared over 8 and plus c. And from here, I'm bringing back our t, here it is, cubic, here it is, cubic radical 2x plus 1. And we are getting, which is going to be our answer, 3/20 cubic radical 2x plus 1 to power 5 minus 3/8 cubic radical 2x plus 1 to power 2 and plus c. All right. How do I get that 5 and 2? So since our t was equal cubic radical 2x plus 1, right? So we had t to power 5 would be 2x plus 1 to power 1/3 and raised to power 5. And we would get 2x plus 1 to power 5/3, right? Same way we get the t squared. So we get 2/3. All right? Okie dokie. And I'm going to solve next integral of the form sine cosine. Remember in my previous video I marked down that radicals can brought down to integration by partial fraction. Okay, let me see. What is this here? Yeah, 3D, this is multiplication. I just saw it. So you won't get confused what it is. Yes? Okay. And now I'm going to solve another form of integral, that is function of sine x cosine x. We're going to do function integral of function sine x cosine x dx. Okay, let me start solving this one. Problem number 3. Now, for the problems like this, where it's sine and cosine is involved, and I'm going to solve type of dx, sine x plus cosine x. So for the function of that involves sine x and cosine x, we usually do the substitution as a tangent half of x. T is equal tangent half of x. I would recommend to write down this substitution because it's going to be a longer calculation, so you will have it when we go back, so you can use it. And from here we will have x would be equal to arctangent t. Okay, so dx from here is equal 2/1 plus t squared dt, derivative of arctangent. Open the table and you will see that derivative of arctangent is 1/1 plus t squared and dt, I'm sorry, t squared dt. Okay, so from here we need to transfer to t sine x and cosine x, right? Okay, I'm going to follow formulas, and that is the reason why I took tangent half of x and not just x. Because the formula for sine and cosine that expressed through, both of them expressed through tangent, we have to use half of the angle. And this is precisely why I took here half of x. And why I took specifically tangent, because n sine and cosine I can bring to same trig function. Make sense? All right. So, from here, sine x, it's going to be equal. This is, I'm writing down formula. 2. First, I'm going to write down formula. Let me use this red color. Maybe I can use thicker version so you can see. Sine x, it's 2. What am I writing? Hold on. I was writing and thinking if it's not too thick. That's okay. It's going to be 2 tangent half of x over 1 plus, remember this formula? Tangent squared half of x. Yes? And cosine x is equal 1 minus tangent squared half of x, and in denominator we have 1 plus tangent squared half of x. So from here, sine x, it's going to be equal, tangent half of x is t, so we are getting 2t over, and tangent square half of x is going to be 1 plus t squared, right? Okay. Now here, what do we have? 1 minus t squared, and here we have 1 plus t squared. Okay, so going back, so let's solve it, see what we are going to do with this. Dx, that's why I would recommend to write down the substitutions, guys. So it would be easy when I talk and bring back substitution. You can look at your notes and you know what I'm talking about. Okay, we have integral. Our dx, where is it? It's right here. 2 over 1 plus t squared and blah, blah, blah. Let me write down. We are getting 2 dt over 1 plus t squared and divided by sine x is 2t over 1 plus t squared plus cosine x is 1 minus t squared over 1 plus t squared. Okay, this is gonna be equal 2 dt 1 plus t squared, and I'm bringing to common denominator 1 plus t squared, and I will get here 2t plus 1 minus t squared, where this is going to be equal to dt over 1 plus t squared times, because it's division, so denominator, the fraction in denominator we are going to flip, which means we get 1 plus t squared divided by 2t plus 1 minus t squared. We have 1 plus t squared cancelled, and we will end up with negative 2 integral dt over t squared minus 2t and minus 1. And this is where from negative sign we got. This is what I did. I changed the sign. Why? Because I want to make a look form of the quadratic expression, right? T squared minus 2t minus 1. It's incomplete quadratic expression, but we will make it complete. It's not a big deal. That's why I put negative and flip every single sign in denominator. So from here, what am I doing? How I'm going to complete it? I have negative 2 integral. So look here, t squared minus 2t, and I'm supposed to have plus 1, right, to complete my perfect square, yes? Okay, so I put plus 1, but because I dare to disbalance the fraction, I'm going to make sure it won't be disbalanced, so I added 1, I subtract 1 right away, and this negative 1 that was there, I'm writing down right here, minus 1. Are we clear? dt. So this piece, it's gonna be my perfect square, and I'm going to get negative 2 integral 1 dt, and I am getting t minus 1 squared minus 2. Okay? Let me see. Okie dokie. From here, we are going to move to simplification by partial fraction. What we're gonna do? I'm going to write down here 1 over t minus 1 squared minus 2 is equal a over t minus 1 minus square root 2. This is t minus 1 squared minus 2. It's going to be our difference of squared, which means I'm going to have this one here. Oh, it's very thick. Hold on. I'm going to have here t minus 1 minus square root of 2 times t minus 1 plus square root of 2, right? Difference of squared. This is a squared, this is b squared. We good? All right. So, plus b over t minus 1 plus square root of 2. Okay. So, from here, what we are going to get, I have 1 is equal, bringing to common denominator, it's going to be obviously t minus 1 minus square root 2, t minus 1 plus square root of 2, right? So it's going to be at minus a times 1 minus square root of 2, because I put minus in front, right? Okay. Let me see if I confused you or not. Maybe I should put a times t. Okay. Let me go this way. A times t minus 1 plus square root of 2. Okay. Plus b times t minus 1 minus square root of 2. Okay? So from here, I'm getting, since I don't have any t, it's going to be 0t plus 1. Right? And I will get at. Now, when I distribute by this and this, I'm not going to distribute separate by -1, by square root 2, because both of them are available term. Instead, I'm going to write down minus a, because I put minus, so every single sign in parentheses is going to flip, right? -1 will become +1, positive square root 2 will become negative square root of 2, correct? Plus bt, and also minus b, because I have minus b, then signs in the parentheses going to change. -1, negative square root 2 will become 1 plus square root of 2. Okay, so from here, I'm creating system of equations. So this is at with t, this is bt. So coefficient I have on the left side is 0, which means I will have a plus b is equal 0. On the other side of this negative a times 1 minus square root 2, negative b times 1 plus square root 2, those are available terms, which is going to be equal to the left side. The available term is 1. So we get negative a, 1 minus square root of 2, minus b, 1 plus square root of 2, equal 1. I'm going slow not to make silly mistakes myself. Okay, so from here, what do we get? Okay. To solve it, obviously, I'm going to take a is equal negative b, right? Okay, so if a is equal negative b, so negative a is going to be positive b, correct? And we write down b times, plugging to the second equation, right? B times 1 minus square root 2 minus b, 1 plus square root 2 equal 1. Okay, taking b out as a common factor, and I have 1 minus square root 2 minus 1 minus square root of 2 equal 1. So 1 and 1 is gone, and we have negative 2 square root 2 times b equal 1. And b is equal, right here, b is equal negative 1 over 2 square root of 2. All right, so from here, what do we have? Accordingly, a is equal negative b, which is going to be positive 1 over 2 square root of 2. All right, once we have it, now we are moving this back to our original integral, where we have, let me copy this. Okay, well, I can't remember. So going back to blue color, so integral 1 over t minus 1 minus 2 dt, getting too close, where it was equal integral my ugly integrals. Okay, integral a over t minus 1 minus square root of 2 dt, it was minus, right? Yeah, with minus. A I took with minus, plus integral b t minus 1 plus square root of 2 and dt. Okay, so from here, and we took negative 2 out, right? Yeah, we have negative 2 here also. See? Negative 2. All right. So I can take all these. 1 second. Okay. There we go. So what am I going to do here? I'm going to plug, so it's equal negative 2. A is integral. My A is 1 over 2 square root of 2, right? And I have here t minus 1 minus square root of 2 dt plus b is negative, integral negative 1 over 2 square root of 2 t minus 1 plus square root of 2, right? And dt. Okay, so what do we get from here? I'm going to take out 1 over 2 square root 2, and we are getting negative 2 times 1 over 2 square root of 2. And this 2 and 2 is gone. And we are getting here, we have here integral t minus 1 minus square root 2. Now, I have dt. Since I have negative 1 minus square root 2, both of them are constants, right? There is no variable in there. What am I'm going to squeeze in the same thing under under this derivative, which I can put minus 1 minus square root 2. I can clearly do that because derivative of these numbers is going to be 0 anyway. So you can put bunch of numbers under derivative. It won't bother anybody at all because derivative is going to be 0. So the same way here, minus, I'm putting here minus. This is this sign. I didn't use it. Now I'm using now. Okay, it's going to be minus. Wow. Minus. Same way here, dt minus 1 plus square root 2 over t minus 1 plus square root of 2. Okay? And as a result, we are going to get negative 1 over square root of 2 natural logarithm, right? T minus 1 minus square root of 2 minus natural logarithm t minus 1 plus square root of 2, right? And since we have subtraction, what can we do? Subtraction of subtraction of logs is equal division of logs, right? Let me write down. Okay, I didn't change the thickness. 1 second. Log A minus log B is equal log A over B, as long as base is the same. Okay, so from here I'm writing down negative 1 over square root of 2, and we are getting natural log absolute value t minus 1 minus square root of 2 divided by t minus 1 plus square root of 2. and plus c. I'm bringing back now substitution of t, right? Which is going to give me -1 over square root of 2 natural log absolute value tangent x over 2 minus 1 minus square root 2. Remember I told you, right, keep these notes, write down the substitution I'm doing here. And we have tangent x over 2 minus 1 plus square root 2 and plus c. All right. As always, thank you for watching and I'll see you next time.